but I saw the news.
Oh,
Okay, now we'll come back to the chapter because we don't have much time. So, atomic structure, if I will understand atomic structure is basically the compositions of the or the structure or the properties that are correlated. We are going to learn in the atomic structure chapter. Okay, why atomic structure is needed? Because if an atom has a different atomic structure, then it will have different properties. Means atomic structure is for the defining the chemical and the physical property of a atom. Are you with me? Did you
yes,
understand?
yes, sir. So
Okay.
each atom has a different atomic structure.
Yeah, different. Like for example, I'll talk about carbon. Now, carbon is basically has a different atomic number. Like carbon atomic number is 6, and if carbon atomic number is 6, then it has 6 electrons and 6 protons. If
Yes.
I'll talk about nitrogen, nitrogen does just 1 electron is extra, and 1 proton is extra.
Mhm.
Did you understand?
Yes, sir.
So 1 electrons and 1 proton extra makes the different property, means different element. So what's the difference between carbon and nitrogen? Just the number of electrons and number of protons are arranged in a different manner.
They're not
So
adding
we,
in a different manner. They're just adding one electron and one proton.
yeah, adding just 1 electron and 1 proton makes the another element. Okay.
Yes, sir.
So now we are going to learn what we will learn in this chapter. So first topic is discovery of fundamental particles of atoms. So we'll not go too much deep in this because we already learned this in the 10th class. Okay, so first is discovery of electron. So discovery is electron by J.J. Thomson. Can you read this page? Just not full paragraph, just one line. When I say stop, then you can stop. Okay. First line, can you read this?
Okay. In 1897, J.J. Thomson discovered electron as a constituent of atom. He determined that an electron had a negative charge and had very little mass as compared to that of the atom. Since an atom was
Perfect. Only, okay, okay, perfect. So, means electron is the first constituent particle that has been discovered. It is negative charge and the mass is very less. Very less. Okay. And then second one is protons. It is discovered by uh, E. Goldstein or Rutherford also. And then its mass is like it's comparable more than the electron. So like 10 to the power minus 27 is proton mass kg, and 10 to the power 31 is the electron. Now
minus 31. So minus
it's
31.
like yeah, minus 31. So it's like 1,000 kilo difference.
Thousand
Like
times,
one,
1,000 times
uh,
smaller than.
yeah. If 1 kilo banana is on electron side, then 1,000 kilo banana is on proton side. It's that much different. Did you understand?
Yes, sir. I understood everything, sir.
Then neutron is discovered by James Chadwick
Chadwick.
in in 1932. Okay, and it is neutral. There is no charge in it. You have this value. You have to learn this value. Okay, proton
Yes.
mass and electron mass.
So I
Okay,
know all the masses and the charges also, sir.
perfect. Okay, now we will learn about some atomic number, mass number, isotopes, and isotopes. So I'll just give a quick review in this for your information. So atomic number is denoted by Z,
Yes.
which means number of protons.
Mm.
What does it mean? Number of protons. Number of protons means like how many protons are there. For example, if an atom atom, if Z is 6, so it means that number of protons
It's six.
is also 6. Okay, and this atomic number Z is also equals to number of electrons, but with a star mark. Number of electron, but with the star mark.
The
Now, what is
ion.
the meaning of star mark?
Basically,
Star.
ions. If ions are
Yeah,
there, for example, if it's a cation means there'll be less electrons. If it's an anion means there'll be more electrons like that.
yeah. This means that the star mark means if no charge is there on the atom. If charge is there, then in that case, number of electron it won't be one. And then mass number that is denoted
A.
by A, which means number of protons plus number of
Neutrons.
neutrons. Okay, and because basically then protons and neutrons are uh, concentrated in the nucleus only, no? So the number of protons and number of neutrons are heavy also. So they are only responsible for the deciding the atom uh, weight. What will be the mass of atom? Did you understand?
Yes, sir.
Okay. So atomic mass or mass number, they both are same. Okay, and in an atom, for example, X atom is there, then Z will write in the atomic number and A will write in the mass.
Yes, sir.
Okay, you understand?
Yes.
Now we'll learn about isotopes. No, no, चिल्लाना नहीं है. Okay. Isotopes. What is the meaning of isotope?
Isotopes means it will have the same atomic number but different mass number.
Yes, same atomic number but different mass. Same, sorry, mass, no, correct. I'm wrong. So same atomic number, but different mass number. So can I take one example?
Yes, sir.
C612
And
and
C614.
C640. So they have same atomic number, but different mass number.
Yes. And
And why?
um
Why they are become isotopes?
because they have same atomic number but they have different mass number.
No, no. Because of which subatomic particle they become an isotope? Because
Like
of what?
neutron.
Yes.
Like
Because there's a difference. Yes.
like here in C612 there are 12 there are 6 neutrons, but in C614 there are 8 neutrons. So there are
Yeah.
2 extra neutrons in C614 compared to C612. And by the way, C614 is the radioactive isotope.
Yeah. So because of the difference in the electrons, because it's a in the neutrons, because of the difference in the neutron, this is basically uh, uh, we can see there are two isotopes out there. Do you understand? Yes or no?
Yes, sir. Understood.
Now, one more. In this, in isotope, they have they have same chemical properties because both are carbon and carbon, no? So
Yes.
they have same chemical property, but different physical property. Now, different physical property. Correct. So from this, what we can make the thing out? We can make one thing out that if you will change only neutron in an element or in an atom, then then we will have a change only in the physical property.
Yes, sir. Because same element. So same element means same chemical property. But
Yeah,
the number of neutrons are varying, so the physical properties also will vary.
So if it is MCQ, it will come that which is responsible for the change in a chemical property is number of protons or the number of electrons, not the number of neutrons.
Okay.
Do
So
you understand?
yeah, yes, sir. So when MCQ comes in NIOS or JEE Mains or JEE Advanced, I have to say like this, right?
Yeah, because physical property, right now only we can see that here the physical property is changing because of the change in the number of
You,
neutrons, not protons.
yeah.
Okay, so
Now,
I'll,
like if they give
yeah,
like the change in the number of dash gives the change in physical property, but not the chemical property. The options will be protons, photons, neutrons, and electrons. You have to
correct,
pick the answer of neutrons. Yeah.
correct. Now, for example, this is hydrogen, this is deuterium, and this is tritium. Hydrogen, deuterium, and tritium. So there they are the three isotopes of hydrogen. Did you understand? Now
Yes,
quickly
sir.
write it down.
I understood,
Quickly
sir.
write it down. Yeah, quickly write it down this thing.
The isotopes thing.
Yeah. I mean you can write from here because I'm not going in deep and writing so much, so you can write this notes from this atomic number. If you didn't understand, ask me better.
Sir, and by the way, the hydrogen three, the tritium is radioactive.
Yeah, tritium is correct. Done writing?
Not yet, sir.
Shall we write it down, okay? Then
Done, sir.
okay. So now we'll talk about the isobar. Okay. Now what is isobars? So can you tell me?
Isobar will have the same mass number but different atomic number, like C614 and 7 and 14.
Yeah. Correct. So isobars. Okay. So what does this mean? They have same mass number but different different chemical different atomic number. Correct?
Yes.
So for example C614 or N614.
And
Got it?
seven and 714.
N714. Right? Okay. So now in this we can see that the number of proton is 6, number of proton 7,
Yes,
number
sir.
of electron 6, number of electron 7. But carbon atomic number, carbon number of neutron
Uh,
8,
eight.
8 no, and
Yes.
in this 7.
7.
Okay, so because here in the carbon we have extra number of neutron, we can see the isobars. Got
Yes.
it? Now,
Yes.
because they are the different elements only, so we can conclude that they have different chemical property. We can conclude.
But physical properties also will be different, right? Because they are
Yeah,
different.
physical properties are also different, but different chemical properties is the main point.
Yes.
Got it? Write it down. Write it down.
Done, sir.
Okay. Done? Now put a heading. Thomson model.
Done, sir.
Okay, guys. Okay. Now put a heading Thomson model, and will not go too much deep in this. Just write the main point of this, because we all know what is Thomson. So, Edric, can you tell me the main points of that?
Okay.
It is
Main
given
point
by
of
J.J.
Thomson
Thomson.
model is okay. So first, the Thomson, so a man named J. Thomson discovered this model of atom in 1897, and he said that the atom mm, the atom has electrons inside of it with a sphere of positive charge all around it. This model
Hmm.
is often called as watermelon model or the plum pudding model.
Correct. So basically, at that time, electrons were not like discovered. It is said that there is a positive part. So that is why he just made it like this, saying that electrons are the like a seeds in the watermelon, and the rest, the red part is a positive sphere. So he didn't say proton. He says positive
Positive
sphere.
sphere. See, like for example, In the watermelon, no, the red part inside, the red part is the positive charge, and the seeds are the electrons, like that.
Yeah, this is positive
Positive and
pair.
yeah, positive sphere and contains electrons.
Uh, now, so it got like rejected because having a negative charge embedded in the positive charge makes the atom unstable. Because of that instability, atom cannot handle that. It's gonna be look like this, that the table is there and automatically table get bombarded
Okay.
because if electrons are embedded in the positive charge, it makes really unstable. But it's not happening, no?
Yes, sir.
Okay. So now second one is Rutherford model. So Rutherford model also we know, but Rutherford model some questions used to come. So that is why we cannot go just brief. We'll take point by point. So we all know the points. Okay, we all know what Rutherford did. What Rutherford did?
Okay. So Rutherford, like first, Rutherford, he performed an experiment which is called as alpha ray scattering experiment.
Hmm.
And in
Then
that alpha ray scattering experiment, he took like a source of something called as alpha particles, a source of
hmm.
alpha particles, and then he smashed those alpha particles into a very thin gold foil.
Correct.
Because like gold is heavy and gold is like it doesn't like react with others. That's why he took gold, and
Hmm.
so he smashed the alpha particle through the gold foil, and later
Now what is
and
alpha particle is made up of?
so alpha particle is made up of helium nuclei minus the two electrons.
Yeah, you can write He, like when if the in MCQ it will come. So it's basically helium particle plus two, or it's gonna be looks like this, or some book also written as plus two, like this.
Yeah, helium double plus.
Means basically why he did double plus, because he wants to remove electrons from the helium particle. So if you will remove the electrons, then helium or the alpha particle is become a positive particle. Correct? No.
Yes, sir. Okay,
Like
so
for example, he cannot take sodium because removing all the 11 electrons, okay, it gonna and then having 11 protons, then it is very unstable. No electrons, no stability. So instead of that, he took helium particle in which he removed two electrons so that this can become a positive particle and he can bombard with the gold foil to check the reaction.
and so why didn't he use hydrogen instead?
Hydrogen was like helium is a noble gas,
Mhm.
inert gas. Okay, hydrogen is not an inert. So there is many complications were there. Plus, the hydrogen achieving that position is not possible. Okay, and he need a positive particle that is strong positive. Here we are getting two plus plus. No, hydrogen we will get only one plus.
Yes.
So these are the reasons because helium is an inert and it won't react with the gold plus.
Now he smashed the alpha particles through the gold foil. Okay, so
Hmm.
before the experiment, the people thought that basically all the alpha particles would just pass straight through the gold foil without any deflection.
Hmm.
But when he performed it, it was found that like 99.9 particles of 99.9% of the all the alpha particles pass through the gold foil. Then few particles, they were deflected at a very small angles. Then
Hmm.
like very few particles were deflected by very large angles, but about 1 in 20,000 particles experienced a rebound.
Correct. Correct. So from this we can conclude okay the experiment which we did. We can conclude three things. Write it down that three things. Quickly write it down. So the conclusion is First, atom contain some dense atom contains some dense positively charged atoms contain some dense positively charged region region located at the center of it. Located at the center of the atom.
Atom that we call as nucleus.
Nucleus. Yeah. We call as nucleus. Second point. Second point is all positive charge, all positive charge and modes of its mass, all positive charge and most of its charge are contained. Most of its
Mass are
mass are
contained in the nucleus.
in the nucleus. I did not. And the third part is rest of the atom, rest of the atom would be empty space, would be empty space which contain which contain smaller and negatively charged particles, smaller and negatively charged particles, which called as electron, called as electron.
Yes, sir.
Okay. So now we are going to learn. Okay, why it got dismissed? Why this proposed theory got dismissed? Can you tell me?
Because here it would mean that the electron would continuously radiate energy, which means the electron would just go round and round and round and round and fall into the nucleus, and the entire world will go dishoom.
Correct. So basically, when it is asked that, okay, sir, you give me the position of nucleus, the position of neutron and proton, but where is the electron? Is that the electron is revolving around the nucleus. If electron is revolving around the nucleus, so anything, if it is revolving, if it is doing some motion, it radiates energy. So it may happen that an electron will lose the energy, and because of the positive charge, it will attract towards the nucleus, and it can go and embedded in the nucleus, and there's a shoom bomb. Okay,
Yes,
you
sir.
understand?
Yes, sir.
So write it down the limitation or the failure. This can come in 2 marks or 3 marks. Please write it down. According to the Maxwell theory of electromagnetic radiation, according to the according to the according to the what was I saying? Maxwell theory of electromagnetic radiation,
Yes.
a charged particle, a charged particle undergoing a charged particle undergoing acceleration undergoing acceleration would continuously emit would continuously emit radiation and lose energy. Like electron is a charged particle, when it is in moving or in the acceleration motion, it will radiate energy. This is Maxwell's theory of electromagnetic radiation. Since the electrons, lose energy, okay. So
Yes.
as a consequence,
What's that?
as a consequence, the electron moving, as a consequence, the electron moving around the nucleus, around the nucleus, would approach and follow the spiral path. Would approach the nucleus and follow the spiral path, and at last it will collapse into the nucleus, and at last it will collapse into the nucleus and 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 become unstable and become unstable. Become unstable. This is the reason. This is the reason where Rutherford atomic theory got rejected.
Hi, Agatha.
Hi, David.
I'm not David, I'm
No,
Eddie.
no, no, no. So I mean, hi, Edric.
I'm, oh, hi. I'm seeing you after a long, long time.
Okay, so Edric will do till here only because next topic is electromagnetic radiation, and that we are going to do tomorrow. Okay,
Okay,
so
sir.
today's homework is in-text question 2.3.
Okay, sir.
Okay, and two questions answer I guess we give, so don't do the two questions. Rest question we do. Okay,
Okay, sir.
question number four we did, and question number third I guess we did. Question number one and two is video. Okay,
Yes.
do you do this?
Yes.
Okay, so with this note, we end this class. I hope you've enjoyed the class at this. We'll meet tomorrow for the electromagnetic radiation.
Okay. Bye, sir. See you
Bye.
tomorrow.
Paka. Bye bye. Yes, we'll wait for 2 minutes. Let them come. And then we'll start the